This video is brought to you by mywayteaching.com.
So now I will explain you about the gas laws. In that, the first one is Boyle's law. Boyle's law here this is also called a pressure and volume. Okay, pressure and volume relationship. We are calling this as pressure and volume relationship. Robert Boyle reached to the conclusion that at constant he states that at constant temperature, okay, at constant temperature the pressure of a fixed amount of gas varies inversely with its volume. Okay, pressure is varies with its inversely with its volume. This is known as Boyle's law. Okay, that is P is inversely proportional to the volume at T is and N constant. Here T and N are constant. Okay, and see the note down this statement and see here, that is P is inversely proportional to V. Okay, and we can write it as P is equal to K1 into 1 by V, where K1 is equal to proportionality constant. It is proportionality constant. Okay, and the next one is K1 depends upon the amount of the gas, temperature of the gas, and the units in which P and V are expressed. So we can write it as PV is equal to K1. Okay, and it means that at constant temperature product of pressure and volume of a fixed amount of gas is constant. Product of pressure and volume, okay, product of pressure and volume of a fixed amount of gas is constant. If a fixed amount of gas at constant temperature T occupying volume V1 at pressure P1 undergoes expansion so that volume becomes V2 and pressure becomes P2, then according to Boyle's law. See, I will write down here. This is one part. Okay, PV is equal to K1. It means that at constant temperature product of pressure and volume. See, at constant temperature product of pressure and volume, okay, of the fixed amount of gas is equal to constant, which is equal to constant. Okay, see, I will write down, if a fixed amount of gas at constant temperature T at constant temperature T, what happens, occupying that volume V1 and pressure P1, consider, okay, undergoes undergoes expansion so that volume becomes V2, volume becomes V2 and pressure becomes P2. Then according to Boyle's law, P1 V1 is equal to P2 V2 is equal to constant, so that P1 by P2 is equal to V2 by V1. Got it? So this is the Boyle's law. Okay, this is Boyle's law. How? What happens at constant temperature P1 V1, which undergoes the expansion so that it becomes P2 and V2. So according to the Boyle's law, it is like this: P1 V1 is equal to P2 V2. You should know PV is equal to K1. What is how this is explaining? You have to write the Boyle's law statement. So here this is called pressure volume relationship, that is PV is equal to K, that is pressure volume relationship. So and you have to explain this also. Okay, next uh, this is as shown in this figure, graph of pressure versus volume V of a gas at different temperatures. So when at 200 Kelvin and 400 Kelvin and 600 Kelvin, pressure versus volume. Okay, and see here, as in shown in this figure, two conventional ways graphically representing the Boyle's law, as this is one figure. Okay, so the value of K1 for each curve is different. Here K1 is different for each curve. Okay, K1 is different for each curve, is different because for a given mass of a gas it varies only with the temperature. Each curve corresponds to a different constant temperature and is known as isotherm. Each curve, note down this, each curve corresponds to a different constant temperature and is known as isotherm. Okay, so higher curve corresponds to higher temperature, and it should be noted that volume of the gas doubles if temperature is halved. Okay, next, this is graph of pressure of gas, uh, P versus inversely proportional to 1 by V. Here as shown in this figure, it is a straight line passing through the origin. It is a straight line passing through the origin. However, at high pressure gases deviate from Boyle's law, and under at such conditions a straight line is not obtained in the graph. By definition of by definition, density D is related to the mass. So this is over, this is the how what happens. Okay, this figure is over now. So come to the definition, density D, okay, it is related to the mass M and volume V by the relationship, that is D is equal to M divided by V, and here M is the mass and V is the volume. Okay, if we put the equation, if we put the value of V in this equation, if we put the value of V in this equation from Boyle's law equation, we obtain the relationship D is equal to M divided by K1. Okay, that is P. Okay, this is K dash P. Thus shows that at a constant temperature, pressure is directly proportional to the density of a fixed mass of the gas. Okay, so this is about the density and equation, and you are putting this volume V is equal to, we know that V is equal to K1 into P. Okay, then putting that K1 P, and so you are getting K dash into P. Okay, so this is where it is directly proportional. Next, this is the effect of pressure on the volume of 0.02. This is effect of pressure on the volume of 0.02 mole carbon dioxide gas at 300 Kelvin. Okay, so this is the pressure, volume 1 by V and PV, and this is the effect of pressure on the volume of 0.02 mole of carbon dioxide gas at 300 Kelvin. Problem: a balloon is filled with hydrogen at room temperature. It will burst if pressure exceeds zero point 0.2 bar. If at 1 bar pressure the gas occupies 2.27 liter volume, Up to what volume can balloon be expanded? So here they are asking what is the volume, right? At what volume the balloon can be expanded. So I will explain you the solution here. Okay, in the solution, first write down, we know that according to the Boyle's law, according to Boyle's law, P1 V1 is equal to P2 V2. We know this. If P1 is in given, if P1 is 1 bar, V1 will be 2.27 liter. If P2 0.2 bar, then V2 is what? So from the equation 1, you can find V2 is equal to P1 V1 divided by P2, and write down, apply this one, 1 into 2.27 divided by P2 is 0.2. So how much you are getting? 11.35. This is the volume, that's why I write in liter. So since a balloon burst at 0.2 bar pressure, the volume of balloon should be less than 11.35 liter. Okay, this is the problem solution. Next concept is Charles law, that is temperature volume relationship. Boyle's law is Boyle's law is pressure volume relationship, and Charles law is temperature volume relationship. What is temperature volume relationship or Charles law states? I will explain. For a fixed mass of gas at constant pressure, volume of a gas increases on increasing the temperature and decrease on cooling. So volume of a gas increases when you are increasing the temperature, and volume of the gas decreases when you are cooling. Okay, so when there is a decreases in temperature, so it status that uh, pressure remaining constant. Okay, pressure remaining constant, the volume of a fixed mass of a gas is directly proportional to its absolute temperature. Yes, it is directly proportional to absolute temperature. So here for mass of at constant temperature which decreases on cooling, they found that here Charles he found that for each degree rise in temperature, volume of a gas increases by here just note it down, what is the Charles law status, and I will explain it in detail. Okay, see, as I am saying that so at constant pressure, volume of a gas increases on increasing temperature and decreases on cooling. They found that each degree rise in temperature, volume of a gas, each each degree rise in temperature, each degree rise in temperature, volume of a gas, volume of a gas increases by 1 divided by 273.15 of the original volume of a gas. original volume of the gas at 0 degree Celsius. Thus, if volume of the gas at 0 degree Celsius and T degree Celsius, okay, thus write down this one. Thus, volume of gas at 0 degree Celsius and T degree Celsius are V naught and Vt respectively. So that Vt is equal to V naught plus T divided by 273.15 into V naught. So here you can take V naught common, so that 1 plus T divided by 273.15. Okay. Next, you can write like Vt is equal to V naught into taking LCM 273.15 plus T divided by 273.15. Okay, so at this stage we define a new scale of temperature such that T degree Celsius on new scale is given by, so we can say that T is equal to 273.15 plus T at 0 degree Celsius will be given by T naught is equal to degree Celsius is given by T naught is equal to 273.15. This new temperature scale is called the Kelvin temperature scale or absolute temperature scale. This is we are calling as Kelvin temperature scale. Okay. Thus, the 0 degree Celsius on the Celsius scale is equal to 273.15 Kelvin at the absolute scale. Note that degree sign is not used while writing the temperature in absolute temperature. So, when this is called Kelvin scale or absolute temperature scale, okay, absolute temperature scale, okay, and we are not expressing this in a degree, we are expressing it in a Kelvin. Kelvin scale of temperature is also called thermodynamic scale of temperature and is used in all the scientific works. Okay, Kelvin scale temperature is also called, write down, Kelvin scale temperature is also called as thermodynamic scale. Okay, before going to next concept, again once again I will discuss about this topic. Here please note it down. Decreases on cooling temperature, it always depends upon the temperature only, so that when you are increasing the at constant pressure, the when you are increasing the temperature, volume of the gas increases and it decreases, like, and what is the, it is the status. Okay, and next we can say that so each degree I am telling there is a increases in temperature, what happens, so water increases in the volume also, so that is 273 and original volume of the gas at 0 degree Celsius. Thus volume of a gas at 0 degree Celsius and T degree Celsius, you write it. Okay, and the next one is Vt is equal to this one, T is equal to this, and T naught is equal to this one. Okay, this is called Kelvin temperature scale, or it is also called as thermodynamic scale. Okay. Next, this is the volume versus temperature degree Celsius graph. And I will explain you about this one. Before going to that, the Celsius temperature to obtain at Kelvin scale, if we write T1 is equal to 273.15 plus T and T naught is equal to 273.15 in the equation. Okay, so we can obtain the relationship like this. Okay, this one I will explain you here. So write it down. If we write TT is equal to 273.15 plus T, and T naught is equal to 273.15. If we substitute in equation, sub in equation, it is Vt is equal to V naught into 273.15 plus T divided by 273.15. Okay, so what we are getting, Vt is equal to V naught into Tt divided by T naught. Okay, and you can write Vt divided by V naught is equal to Tt by T naught. We can write it like this: V2 divided by V1 is equal to T2 by T1, and you write like V1 by T1 is equal to V2 by T2, or V by T is equal to K2, where K2 is equal to constant, or you can write V is equal to K2 into T, like this. Okay, so the volume of constant K2 is determined by the pressure of the gas, its amount and unit in which volume V is expressed. So now this is the what does we add 273 to the Celsius temperature to obtain the Kelvin scale. So we are adding, this is for Kelvin scale, and T naught is equal to in degree Celsius. Okay, and if we write detail like this, so this is the derivation. Okay, I think now you got the idea. See, this is okay. Next, this is the figure. Each line of the volume versus temperature graph is called, each line that is called isobar. Okay, we are calling each line as isobar. So observation of Charles law can be interpreted if we put the value of T, okay, in equation of this one. Okay, in equation this equation 1, consider in this equation. So we can see that the volume of the gas will be minus 2, that will be 0 when we are putting minus 273.15. This means that gas will not exist. In fact, all the gases get liquefied before this temperature is reached. The lowest hypothetical or imaginary temperature at which gases are supposed to occupy zero volume is called absolute zero. All the gases obey Charles law at very low pressures and high temperatures. Okay, this is the end concept of Charles law.